For part A, it's asking for, it says, is the speed of the particle speeding up or slowing down? Remember, speed is increasing if velocity and acceleration have the same sign. Speed is decreasing if velocity and acceleration have opposite signs. So which means I got to take the 4, plug it into that velocity function, got a positive number. And then A of 4 means I'm supposed to take the derivative of that to get the acceleration and plug in 4. Remember, the math 8 function in the calculator will do that for us. So math 8, that function at 4, it'll take the derivative, gives you the acceleration at a negative number right there. And since the velocity acceleration have opposite signs, that's what makes that particle slowing down. That speed is going to be decreasing right there. Remember, for part B, a particle is going to change direction when the velocity changes sign, either positive to negative, negative to positive. So like if we're going to the right, velocity is positive, right? And then if we go back to the left, then the velocity is going to be negative right there. So first thing you got to do is find where that velocity is equal to 0, all right? And then the graphing calculator will do this for us. You're going to graph this function right there. It has trig in there, so I hit zoom 7, and then after it graphs it, and then I'm only concerned in between 0 and 3, so I'll hit my window button, make 0 my x min, make 3 the x max, and you should get a portion of the graph that pops up just like this. And it's also perfect justification for the velocity change of sign because it changed from above to below the x-axis. Your velocity changes from positive to negative. So it means you're going to the right, and then you're going to be going to the left where that velocity switches to negative. So to find that number, let the graphing calculator find that 0 for you, right? If you forgot how to do that, please rewatch the graphing calculator video at the beginning of our review here. It gives you that number, and then that's also perfect justification. You have to mention the particle changes direction there since the velocity changes sign from positive to negative, negative to positive, but this one is from positive to negative right there. All right, letter D real quick is like the easiest part of this problem. So it's find the total distance traveled. And remember your total distance traveled formula from your blue packet right here. That means you're going to integrate the absolute value of your velocity function. So you're just going to math 9 that thing, rewatch the graphing calculator video, how to do the absolute value bars, how to do the math 9, just math 9, the absolute value of that thing. And get that 5.301 right to 3 numbers after the decimal. If it asks for the displacement, then you're just going to integrate the actual velocity, and then you give them like that net result. Now, letter C, I have 2 ways to work out letter C. A little bit backwards than what we're used to. We're used to be given the position at t equals 0, and then we find the position at t equals 4, at like 4 or something. So this time is different. It tells us where our position is at t equals 4. We're at x equals 2. And then we want to find where we're at t equals 0. So 2 ways we could do this. If I stick with that same thinking, so we got 0 and we got 4, I'm going to say, okay, my position at 4 is my initial position at t equals 0 plus the integral of that velocity from 0 to 4. So this would be like where we're at t equals 0. And then I'm going to pick up where I left off. So if I started at 0, I would start at 0 here, go to where I want to go. I want to go to at that 4. And then, so this will tell you how far you went in between 0 and 4, and this will tell you your initial position. Now, this is what we're looking for, though. We're used to be given that one, but this is what we're looking for. But we were given that the x of 4 is equal to 2. Here's what we're trying to figure out, so I just carry that down. And then right here, we need to put this into the graphing calculator and math 9 that thing. So if we math 9 and it gives us that, then we move that over, boom, you got that negative 3.815. Okay, so that's good that we get exposed to something that's a little bit backwards like that, so we could handle both things now with the normal situation we've seen a bunch of, and then that one right there. Also, another way, if this kind of makes sense to you, I know it's a little bit, let me kind of zoom in a little bit more on that. It's a little bit difficult, there we go. All right. So what you could do, notice that 0 and 4 are the numbers in question. So you could integrate between 0 and 4 because this is what you're trying to figure out. This is what you know. And when you integrate the velocity, that's going to get you a position. Plug in the top number, plug in the bottom number. X of 4 we were given was equal to 2. And then the x of 0 is what we're trying to figure out. And then this one, you're still going to have to math 9 that thing. And notice, if you're trying to solve for this x of 0, you can move that over to this side. You could subtract your integral over, and you're going to have pretty much the same stuff that we talked about there. We were given that was 2. We did the math 9 to do the 2 minus the 5.815 and still come up with that negative 3.815 for the decimal right there. All right, so another particle problem done. crayons.